side, your biology mentor Ashutosh Vashisht. I hope you all are doing very fine. Today we are going to learn a very crucial topic in biology, that is double circulation. You guys know that in every chapter there is one topic which is the most significant, which is the soul of the chapter, which is the gist of the chapter. And this is one amongst those topics. So every year, almost every year, a question comes from this topic, because this topic, I guess, is one of the most important topic of this chapter specifically. So today we are going to learn double circulation in humans. So as you can guess from the term, that the circulation is happening for two times, that's why it's called double circulation. But it it is in itself very vague. Like, what, why double circulation, why it is required two times, and where is it happening, is one time not enough, how does it happen? So we'll answer those questions in this class. So double circulation means the blood that is flowing within our body, which is pumped by heart. Heart is the main organ that pumps blood in our body. So the blood that is being pumped from our heart will pass from the heart two times. It will circulate from the heart two times. Let me draw a heart first of all. So suppose this is your heart. It has four chambers. We know from earlier classes that heart has four chambers. So what will happen is that this is the left side of the heart. This is the right side of the heart. So what happens is there would be oxygenated blood. The blood that carries oxygen, that will pass through the blood, or that would pass through the heart blood. And there would be deoxygenated blood, that would also pass through our heart. So blood can be oxygenated, blood can be deoxygenated, and it passes through our heart. So one time it's oxygenated, one time it's deoxygenated, two times the blood is getting circulated from our heart, hence it is called double circulation. So this is the theme, very basic fundamental what's happening in double circulation. But in order to understand it, that how does it happen, why does it happen, we'll have to understand certain concepts. First would be the structure of our heart, and second would be about blood vessels. So first of all, I'll break down the structure of the heart from this figure itself. We know that heart has four chambers. This is one, this is two, this is three, this is four. So heart is divided into two sides, left side and right side. In the left side, which is chamber number 2 and chamber number 4, only oxygenated blood will flow. Similarly, in the right hand side, in the chamber number 1 and 3, only deoxygenated blood will flow. So, right now when you are seeing at the screen, in front of your right hand side, it would be left part of the heart, but don't get confused with it. There's a trick. Always do this thing, that this is your left hand, my left hand. So this so on this side only, left side of the heart would be present. Similarly, this is my right hand, and here right side of the heart would be situated. Left side will deal with oxygenated blood, right side will deal with deoxygenated blood. I guess that is very clear to you. Now, if we divide the heart into upper part and lower part, now this chamber number 1 and 2, they are situated up on up this above this central line. So they are called atrium. Atrium is a similar term when we refer to two of them, that would be atria. So atria is plural, atrium is singular. And the chambers which are situated below, they are called ventricles. Now, what does atria do and what does ventricle do? Atria always accepts the blood into the heart. So A for atria and A for accept. And what does ventricle do? It will tell the blood to leave the heart. So V in the end of leave and V in the beginning of ventricle. So always the blood would enter from atria. Either it would be 1 or 2. Suppose it's the left side. It will receive or accept the oxygenated blood, this atrium. This is ventricle. and this is on left side, it will make the heart to leave oxygenated blood. So ventricle will make the heart, blood leave, and oxygenated blood or any kind of blood would be accepted by atrium. Similarly, on this side. So I guess this is clear to you. Now we'll name them. We'll name each of the chambers. I have written here 1, 2, 3, 4, but this is not the right thing. Every chamber has its name, which is like this is situated in the left and this is on the upper side. So it would be left atrium. I'll write it as LA from next time whenever I'll draw this figure. What would be 4? It would be left ventricle. What would be the third one? It is situated in the right side and the blood will leave from here. So it's right ventricle. And this is upper side and right side. This would be right atrium. So this nomenclature you have to remember. But you don't have to remember if you have understood the concept of left and right and the upper and below, what accepts and what makes the blood leave. So you will understand that how do we name them. So this is the structure of heart. Basically, I am building fundamentals here in order to make the concept of double circulation easy. Till now, we have not come to the concept of double circulation yet, but yeah, we are moving towards it. But first, let's get the basics clear. Now I'll tell you the concept of blood vessels. So, how the blood flows in our body. I'll give you an example. In your house, there is a water storage tank on the roof. And when you open a tap below, the water comes. So, how the water is traveling? They are traveling through pipes. Similarly, in our body, there are blood vessels, which are basically pipes, or they are technically more right, they are ducts. They are tube-like structure, which are ducts basically, and called blood vessels. And there are two types. First is artery, second is vein. Now, arteries, what they will do, they will accept the blood. Sorry, I'm so sorry. They will take the blood away. So, whenever the blood has to leave from the heart, it would be through artery. They will take the blood away from the heart. A for away, A for artery. Again, artery. And what about vein? They will welcome the blood. So, W welcome and V vein. The sound is same. The starting sound, vein and welcome. So when the blood has to enter the heart would welcome the blood through veins. I hope you get it. This would be used when I'll tell you the concept of double circulation. Now, arteries and vein is clear to you. Just one last thing, and then we'll move on to the main concept. You must have learned about you must have come across a term called hepatic. Whenever you come across this term, it is related to liver. If you come across a term called renal, it is related to kidney. So for lungs, do you think there would be a term like from anatomical perspective? Yes, of course there is, which is pulmonary, and this is related to lungs. So whenever you listen to a term pulmonary directly related to lungs, let me give you an example. Suppose you got to listen that someone is having pulmonary cancer. So that person would be having a tumor in his or her lungs. So pulmonary, you got it. Now what we'll do is we'll come across some terms like pulmonary artery and pulmonary vein. So the artery that would be connected to lung would be pulmonary artery. The vein that would be connected to lung, that would be pulmonary vein. Easy. Now let me tell you what actually happens. I'll make a very simple diagram of heart. You know that heart has 4 chambers. Consider this as a heart. We'll have 4 chambers. Let's name them. Now, this is left side and upper side. This would be left atrium. This would be left ventricle. This would be right atrium and this would be right ventricle. Simple. So this is our heart. Our heart will receive oxygenated blood from the lungs. Suppose these are lungs and they would provide oxygenated blood. Okay, what is oxygenated blood? Let's understand that. Suppose this is a body part. It could be like your muscles, any tissue, any body organ, like intestine, stomach, your eyes, your brain. So in order to function well, in order to carry out its metabolic activity, it will need energy. It will carry out respiration. And what happens in respiration? O2 is needed, oxygen is needed, and CO2 is released. So oxygen is needed and CO2 is released. This is our body part. Any of the body part you can consider. So how will this oxygen and CO2 would travel inside our body? That would be through our blood. So when the concentration of oxygen is high, that would be called oxygenated blood. And how this concentration of oxygen would be high? It would be through lung. So whenever the blood will pass through the lungs, what it will do is it will take oxygen from the environment and pass it on to blood and take CO2 from the blood and pass it to the environment, atmosphere around us. So, respiration, we take oxygen, we release carbon dioxide. That is very basic, fundamental thing that we already know. So now what happens after respiration? This oxygen is added to the blood and this CO2 is removed from the blood. So blood will become oxygenated as the level of oxygen or concentration of oxygen is higher. Now this oxygenated blood will go to heart and heart will pump it. Heart will create a pressure. So this blood via heart will go on to the respected body part. Now this blood that is oxygenated, it is carrying oxygen. This oxygen would be transferred to this body part. It will take up oxygen because it requires it for its metabolic activities. It will take up the oxygen and release CO2 into the blood, and the blood will become deoxygenated. Here I am writing deoxygenated as DO2. Here concentration of CO2 would be higher and concentration of oxygen would be low. Just opposite to what was there in oxygenated blood. In deoxygenated blood, what happened? CO2 is put in and the oxygen has been taken away by that muscle or body part or body tissue. So this deoxygenated blood will again go to the heart. You're seeing this? The blood is circulating through our heart two times. First is the oxygenated, second is deoxygenated. Hence, it is called double circulation. This is the basic thing. So this blood, deoxygenated blood, then goes to heart. Heart will receive it and then it will pass on the deoxygenated blood to lungs. Now what will happen in lungs? As I told you, CO2 would be taken away from the blood and released into the environment. And oxygen from the environment or atmosphere would be put into the blood. Then the deoxygenated blood will become oxygenated. And hence now this cycle will continue to go on. And this cycle happens 72 times. For an average healthy individual, this cycle goes on for 72 times. And this is approximate value. So this is our heartbeat. Our heart beats 7. If you use a stethoscope, you will find out that our heart beats around 70 to 75 times in a minute in a healthy individual. Although if you will start running, this number might go up because then more blood would be required, more oxygen would be required. So more number of pumpings would be required. But normally it's 72 times. So what's happening here is that lungs are giving oxygenated blood to heart, and that would happen through a blood vessel. Now this blood vessel is it to lungs. So it will be called pulmonary. And this is welcoming the heart, or the blood is coming into the heart, or it is leaving from the heart. It is coming into the heart. So heart is welcoming that blood. For welcoming, what I told you, veins are responsible. So that this would be pulmonary vein. Now the blood will go into left atrium, because I told you atrium always accepts the blood. So blood enter into the heart through atrium, and that is left atrium, because we are dealing with oxygenated blood here. From left atrium, the blood will pass on to left ventricle, and now from here it will leave. Ventricle makes the blood leave. So blood is going away from the heart, and whenever the blood goes away, what is responsible? An artery. And here the artery that is responsible is also named. In our body there are multiple arteries, and this is the main artery, or this is the biggest artery in our body, which is called aorta. Now there could be an MCQ, a straight MCQ, that which is the largest artery in our body, and that is called aorta. Remember it. This aorta will be split up into multiple arteries, then capillaries, and will reach out to body parts. Now body parts, what they will do? They will take up the oxygen from oxygenated blood and release carbon dioxide in this blood. The blood will become deoxygenated, and this deoxygenated blood has to be taken to lungs. But we need a pressure. Suppose I'm considering my toe. Uh, my toe muscles are moving, they would be requiring oxygen, so blood is passing into them. But now blood has to come to the lungs. A pressure would be needed, so that for that pressure, heart is responsible. That's why it continuously pumps in our body in order to generate that pressure. So this deoxygenated blood will again go to our heart. And which chamber of the heart? Now the question is, which chamber of the heart? Since this is deoxygenated blood, it would be any of the right chamber. And I told you that atrium is the chamber which accepts. A for atrium, A for accepts. So it will accept the blood here, and will pass it on to right ventricle, and from ventricle the blood will leave. Now this deoxygenated blood is being welcomed by the heart. For welcoming, I told you, it's vein. Through vein it would be welcomed. Now here also, similar to this, like aorta was the largest artery, there would be a largest vein which is called vena cava. From here also one word question or MCQ could be there. This would be vena cava, which is the largest vein in our body. Our heart receives the deoxygenated blood through vena cava. This is the vein. Now when the blood will leave from the heart and it would be taken to lungs, so now you can say this blood vessel which is connecting heart and lung, it would be called pulmonary again. Clear? And since this is taking the blood away from the heart, away is for artery, so this would be pulmonary artery. Actually there is a trick. From ventricles it would always be an artery. So from left ventricle it's aorta artery, from right ventricle it's pulmonary artery, and for atrium it's always veins. So for left atrium you can see it's pulmonary vein, for right atrium it's vena cava. So this is a trick that okay, this is in a cross fashion, you can say. If this is atrium, it would be connected to vein, and if it is ventricle, it would be connected to an artery, AV and opposite VA. So this is the gist of double circulation. Let me revise it for you. Lungs, what they are doing, putting oxygen into the blood and taking out the carbon dioxide, so the blood will become oxygenated. This blood will be received by the heart in the left atrium, and what blood vessel would be responsible for it? It would be pulmonary vein. The blood would be transferred to left ventricle, and then it will leave through artery. Which artery? Aorta. It will reach out to any of the body part, which will take up the oxygen and release the CO2 into the blood, and the blood will become deoxygenated. Now this deoxygenated blood through vena cava will reach our right atrium of the heart. From right atrium it will be transferred to right ventricle, and from right ventricle the blood will leave, and which blood vessel will take it away? That would be artery. And which artery? Pulmonary artery, because it is taking it to the lung. And in lung, what will happen? The CO2 would be released out, oxygen would enter the blood, it will become oxygenated, and this cycle will go on. So this is double circulation, very easy concept. In But you'll have to draw this diagram on your own, so you can get how much you have understood. This diagram, in exam the question could come like they will draw a diagram but they will not do the labeling. They will ask you to label which artery is this, which type of blood is this, whether it is oxygenated or deoxygenated, or which chamber of heart it is. So definitely draw a diagram for it. I hope you have understood the concept. We'll conclude the class here. Thank you.